Hello, welcome to the poster presentation for our paper, Diagram Image Retrieval and Analysis, Challenges and Opportunities for DRA workshop at CVPR 2020. This is Liping Yang. First, I would like to show you some diagram image examples so you have some intuitive feelings for DRA challenges in the rest of the presentation. This example is from industry design database. This example is from patent database. And this example is actually the zoom in detail from this example. One major motivators for our paper is DRA research is much less well developed compared with those for natural images. Because dominant features in diagram images are complex shape and topology. There is no color and intensity features and very little texture information. And zigzag noises are a bottleneck for DRA. Also, diagram images often contain texture annotations such as the figure 4, curve, and arrows. Another major motivator is we want to draw attention of researchers and practitioners in computer vision communities. We want to let them know the computer vision challenges is not just for natural images. There is a large gap to fill in DRA area. We reviewed 4 groups of methods: CVPR, texture, shape, topology, and geometry. For the topology and geometry-based methods, please check my DRA opening remarks for more details. In the rest of the presentation, I will cover the challenges illustrated through our preliminary experiments for the first 3 groups of methods. In the CVPR methods, AHDH, which is adaptive hierarchical density histogram, is the most promising one. So we used it in our experiments. See our paper appendix for technical details about how AHDH works. Then our findings through our experiments are AHDH is not a rotation environment, is lack of some image matching capability, is very sensitive to text annotations such as figure 4, curves, arrows, but they are very common features in diagram images. AHDH is not robust. Let's look at some examples here. It's not a difficult task for humans to tell which 2 pairs of images are very visually similar, but not so for machines. We can see from this image, these 2 shoes are exactly the same. Beyond the left image contains figure 11, but the Euclidean distance values given by AHDH is 4.2. These 2 shoes are exactly the same. Beyond the text annotation is different, and also the rest image contains figure 3. But the Euclidean distance value given by AHDH is 12. The local boundary pattern, which LBP, is a simple and powerful texture-based features in the literature, but it's not a rotation environment. So in our experiment, we used the RILBP, which is the improved version of LBP. See our paper appendix for technical details of how LBP and RILBP works. Our experiment findings do not use texture-based features alone for DRA tasks, combined with other features such as shape descriptors. So RILBP indeed a rotation environment, including for diagram images. This image is slightly rotated from this image. We can see their RILBP histogram is the same. But RILBP cannot tell visual similarities between diagram images. We can see this for diagram images are very different. But the RILBP histograms for the 4 shoes the peak occurs at the same position, but with different amplitude. We use the shape context and RBSD in our experiments because shape context is a dominant shape descriptors for binary diagram image retrieval. And RBSD is the most recent shape descriptors of binary image retrieval. Our findings are both descriptors cannot tell and rank the visual similarities of diagram images well. The labels and annotations in the diagram images really confuse the shape-based descriptors. Let's see some examples. The shape context tells us this pair of shoes is most less visually similar. However, actually this pair of shoes is most visually similar because they are exactly the same image beyond the left image in figure 11. And this third pair image is most visually less similar. RBSD indeed did a good job, better job than the shape context because it indeed can tell us second pair image is most similar among the three, most visually similar among the three. However, RBSD fails to tell us the third pair image is much less visually similar than the first pair. We have seen that there is a lot of DRA challenges. However, this also indicates there is a large gap of opportunities awaiting for us to tackle. The general directions are new image representations, methods and algorithms, and the similarity metrics are needed. And as we can see, it's pretty easy for humans to tell whether two shoes are similar, no matter whether the annotations are different or not. However, it's not so for machines, so psychologically inspired conceptual schemes and theories are needed. The DRA research is much lag behind the natural images is because there are a lot of benchmark data sets for natural image, but not so for DRA. So largely represented benchmark data sets is a really promising direction to go. Topological based images are very promising for DRA challenges. So check my DRA opening remarks for more details for this direction. So through our experiments, we came out some specific opportunities. AHDH is not a rotation environment, so make AHDH rotation environment is a good direction to go. IOPP is alone is not working well for the DRA tasks, so integrate with IOPP with other descriptors such as shape descriptor is a good direction to go. We can see shape context is not working well for DRA tasks, so we need to extend the SC. Some direction examples such as make the SC less sensitive to the annotations in the diagram images. Also, we already see the key points is the shape context depends on the key points. So, and there is a lot of key points in the diagram images. So we need to improve the computational efficiency for SC in order to use it for the DRA tasks. RBSD works better than the SC, but it still have a large space to improve. So especially improve the features used in RBSD. This slide shows the opportunities in terms of application. We already demonstrated that advancing in DRA can help improve the pattern image retrieval. Also, you can see the OCR documents contains a lot of zigzag noises as diagram images faces. So advances in DRA can advance OCR and text recognition as well. Another promising direction is the road lane detection for autonomous driving. Existing current autonomous driving system often assume the road conditions are good, but in the real world, it's not so. We can see a lot of roads contains damaged road lane like this. So this kind of current lane detection methods will not work well for such noisy images. The good thing is this type of noises very similar like zigzag noises faced in the OCR and diagram images. Welcome to check my DRA opening remarks talk for our recent novel DRA work. Thank you.